All right, all right, all right. Well, we're marching our way through Chapter 5, Trigonometric Identities and Equations, and we're now in this chapter section 5-4, Sum and Difference Identities. And corresponds to example 1 in your textbook, page 337. This is the guided practice that we're going to cover in these next two slides. To evaluate a trigonometric expression. Now, let's kind of get some things here. Here we've got our key concepts where we're identifying or showing what our formulas are for sum and difference identities. And of course, here we got our unit circle, which we're going to need to make reference to as we go through this. So let's look at our first problem. We're asked to find what the cosine, or evaluate the cosine of 15 degrees. Well, if we look at our unit circle, we don't have anything that says 15 degrees. We've got 60, we've got 45, we've got 30 going on around the unit circle. But when we're evaluating a trigonometric expression, we can do this, where we can say that the cosine of 15 degrees is the same as the cosine of 60 degrees less 45 degrees. Now, 60 degrees less 45 degrees will give us the cosine of 15 degrees. And here we can see in a difference identity that we can plug in this formula where the cosine of alpha minus beta, in our case 60 minus 45, is equal to the cosine of alpha, or 60 degrees, times the cosine of beta, or 45 degrees, plus the sine of alpha, 60 degrees in this example, times the sine of beta, 45 degrees in this example. So let's kind of fill this in, see what we can do. Hope we got enough room to write. So the cosine, so I'm going to use this right here, is what I'm going to set up. Now, if I look here at the cosine of 60 degrees, I see that that is 1/2. So let's put that in. We've got 1/2 times the cosine of 45 degrees, which is right here, square root of 2 over 2, times the square root of 2 over 2, plus the sine of 60 degrees, which is the square root of 3 over 2, times the sine of 45 degrees, which is the square root of 2 over 2. All right, so let's do a little bit of multiplication. So the cosine of 60 times the cosine of 45, I got 1/2 times the square root of 2 over 2, and that's going to give me the square root of 2 over 4. Numerator times numerator, denominator times denominator, plus, and now I've got the sine of 60 degrees times the sine of 45 degrees. Now let's see, so the square root of 3 times the square root of 2 is the square root of 6. Well, I should read 6. Square root, well, let's just mark that out. Square root of 6 over 4. So now I've got two rational expressions, and I can combine that, and I can come up with a final answer then here, that the cosine of 15 degrees is the square root of 2 plus the square root of 6 over 4. And there we go. we have evaluated the cosine of 15 degrees. We'll do one more. This time we'll do it in radians rather than degrees. Okay, so here we're going to be working with radians, and we're asked to evaluate the trigonometric expression of the sine of 5 pi over 12. And when we're working with radians, that gives us a little bit of a different thing we've got to think about, and that is, how do we convert all these radians that are either a pi over 3 or a pi over 4 or a pi over 6 or some multiple thereof to get into something of 5 pi over 12? Well, and that presents an issue. But if I look at pi over 6, I could actually rewrite pi over 6 as 2 pi over 6, right? That's the same thing, over 12. That's the same thing as pi over 6, right? 2 pi over 12 is the same thing as pi over 6. And let's see, if I look at pi over 4, which is right here, and I express it as to something over 12, well, pi over 4 is the same thing as 3 pi over 12, right? Okay. 3 pi over 12 plus 2 pi over 12 gives me 5 pi over 12. So then I could set this identity up such as this. Then I could say that this is the same as the sine of pi over 6 plus pi over 4. Right? Pi over 6 is the same thing as 2 pi over 12. Pi over 4 is the same thing as 3 pi over 12. 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. All right, there we go. Now, I'm going to identify that the identity that I'm going to use is this one right here, where I've got the sine of alpha plus beta. And that equals the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So so this is what we're going to be using right here. So let's just substitute and fill that in. All right, so the sine of pi over 6, is 1/2. So I can see that right there, 1/2. So let's see, I've got the sine of 1/2, and I'm gonna just erase the whole thing. Let me set this back up right quick. This is the same as the sine of pi over 6 plus pi over 4. Okay, so the sine of pi over 6 is 1/2. So now I've got 1/2. And this is what I'm using right here. Times the cosine of beta. Well, the cosine of beta, pi over 4, is the square root of 2 over 2. And plus, let's see, the cosine of alpha, which is pi over 6 in our case, is right there. So that's the square root of 3 over 2. Times the sine of beta, or pi over 4, which is square root of 2 over 2. All right, so now we're ready to distribute. 1/2 times the square root of 2 over 2 is, well, that's the square root of 2 over 4. Plus, and the square root of 3 over 2 times the square root of 2 over 2, square root of 6 over 4. And since I've got a common denominator, I can just simply add those together, and my final answer for the evaluating the sine of 5 pi over 6 is square root of 2 plus the square root of 6 all over 4. Shazam! There we go. It's not too bad. Got to keep those identities in front of you. Got to keep that unit circle in front of you as we go through this chapter section. Sum and difference identities being used to evaluate a trigonometric expression that is given to us in something that is not in and of itself on the unit circle, but we can use the unit circle using this sum and difference identity to evaluate. Got it? I know you do.